Hello, everyone. I hope you are excited for day 2 of the conference. We will kick things off now with a pre-recorded talk by Aaron Clark, who is a senior data scientist at Biogen, and he will tell us about how to dynamically create UI modules, UI elements that allow you to collect custom data and put them in your data frames on the fly. So have fun and see you soon.
Hey, my name is Aaron Clark. I'm a senior data scientist at Biogen Inc., which is a pharmaceutical company on the East Coast of the United States. Today, I'm going to bring us through a tutorial on how to evaluate user inputs through dynamically produced UI elements. Let's go. Oh, that is a great tune. Okay, so following up, our agenda for the day is going to be addressing the problem at hand. We're going to walk through a use case together and definitely end up dissecting some code, and then we'll just follow up and end the discussion with some conclusions. All right, so the problem at hand, I think that there's a few things that are kind of tricky about today's topic. So what are the big three issues? Well, first of all, there's the task of generating dynamic UI. And then on top of that, bringing together the inputs or extracting those from the UI elements and especially bringing them together in parent modules. And then the final straw is going to be evaluating those results, right, into actual executable R code. I believe the best ways at learning something is usually trial by fire. So we're going to walk through an example together that accomplishes all three of these goals. Enter Shiny New Columns. This is an experimental R package that I've been working on, hosted on GitHub currently, so it's freely available for you to look at and explore. What it is a single Shiny module for users to include in any of their existing applications. It provides a handy user interface to be able to derive new columns in existing data frames that you're working with inside of your app. And I know you might be thinking, wow, why would I ever want my users to actually change data? First and foremost, they're not changing data, they're only creating new data from the existing data. But second of all, sometimes there's some use cases that just make sense. If you trust, the people that are using the application to go ahead and make a new column from some older columns, it can really save a lot of time for different groups and individuals within an organization to put that power into the hands of the users. So what's really neat about it is it's going to evaluate dplyr code on the fly to be able to create these new columns as the user sees fit. So sometimes this is a little hard to understand when you're just verbally, abstractly talking about a package. So in lieu of that, let's just deep dive into a 60-second demo. And if you'd like to follow along, I'd highly recommend that you check out the app for yourself. It's currently hosted on shinyapps.io, but I made this short little link for you, bit.ly/shinynewcolumns. All right, now we can get to the good part. Before we launch the application, I just wanted to bring you to our GitHub page so you're familiar with where the code resides if you're interested in checking it out for yourself. But there is a handy dandy link right here to launch the application that we're going to go through together today. If you scroll to the bottom, here you can see a nice README with some easy installation instructions and also an example. So if you want to use this application, if you want to use this R package in your application, all you need to do is run remotes, install GitHub, Aaron Clark /shinynewcolumns, and you'll install the package. And then this code right here is actually all the code that you need to run the application I'm about to show you. So it's very, very minimal, Here, I'll get my face out of the way. Very, very minimal and reproducible if you wanted to take it for a spin. So let's open that up. Great. Okay, so the first thing that you're going to see here is you have your iris data set, which of course is baked into every R installation. But literally, you could put any data set that you want down here that is specific to your application. Next, you're going to see there's a spot where we can view some dplyr code that's been automatically generated, but that won't deliver any results until after we've derived a column. So the last thing that you'll see here is there's just a simple button. It doesn't take up much real estate, and this is actually the only UI element that exists inside Shiny New Columns. So everything around this application is all just in the app.r, and Shiny New Columns only takes up this much real estate. So it's very, very minimalistic from that standpoint. So when you're ready and you have a data set, you want to create a column, just simply click this button and everything is going to launch in the bounds of a modal. So first and foremost, you're going to see that there's a selector at the top that allows us to choose a column type. So we actually only support a few different categorical column types at this time. So we have a range variable, yes, no flag, and a custom one. So I'll start off here to describe this middle well panel. Essentially, this is going to be consistent no matter what column type you are selecting. And first and foremost, of course, you have to tell us what the name of the new variable is. So for example, you can see I've been busy in the app lately, so it's going to just auto-suggest some old columns. But you select, you can input whatever your new variable name is. If you have a label, we included that, but it's totally optional. And then you're going to have a reference variable. So here you can select any of the numeric values. And the reason why these are subsetted to numeric is because we are looking at creating a range variable. And ranges are going to look at the numeric range for the specific reference variable and create groups based off those ranges. So what's cool here is that you can also see a distribution of the reference variable. So sepal length is going to be plotted over here, or whatever reference variable you want to select. We've specified that we want two groups. And let's say we want to say when sepal length is between 4.3, which is the minimum, it's going to automatically populate this value with the minimum value. As you can see over here, it's about 4.3. And let's just say we want to go up to 6. All right. And you can see that it's actually counting the number of rows in the entire data set. So there's 150 rows in the whole data set. 89 of them sort of fall between this range. That's a lot of rows. So you probably want to just write a description of what that range of values means. So those are our short sepal lengths. And then let's say I want to go from 6 to, oops, sorry, you want to go from 6 to 7, something like that. And you can see that I already got like a little message here. So this is saying that, hey, with those ranges that you've inputted, these numbers do not add up to 150. It only covers 96% of the rows. So in this case, it suggests including an else column. So now that we have that, we can say these are our normal lengths, and then our else group is, we'll probably just call these long lengths. So instead of calling this my new cow, we'll probably want to call it something more descriptive, like sepal length category. And maybe we want to include a label too. So we'll say sepal length category. All right, and that's all you need to do. If you select add variable, you can see instantly it is added to the iris data set down here. So we have a new column over here on the right. And if I sort of scan through my sepal lengths, you can see I have my shorts. If I sort it ascending or descending, we'll see all of our longs. If we scroll down here, we can see we have our normals based off of the value of sepal length. So that's working as expected. And now up here, you can actually see, maybe I'll zoom in on this so it's easier for everyone to see. you can see the dplyr code that was used to create that column. So here you can see we have a mutate statement, the name of our variable, and then dplyr, a simple case one where we say when sepal length is between this number and this number, call it short. When it's between 6 and 7, call it normal. Else, call it long. So that's exactly the code that we generated. The expressions were compiled and then evaluated to create this sepal length category variable. So that concludes the walkthrough of shiny new columns. So let's get back to the slides and we'll continue the discussion. Wow, that was way longer than 60 seconds. I think that was about 5 minutes. So my apologies for that. But the reason why any of that application was cool at all has everything to do with the app structure and how modules were being called. So let's dive into the app structure. Okay, so you know about app.r, but the module underneath is one that's simply called launch modal. And from there, it's going to call one called new call, and the final one is range conditions. So if we were to look for these modules in the app, we would find app.r to be pretty obvious. It's going to be everything that is exclusive of that modal, so everything that's kind of grayed out in this image. Everything that launch modal controls is going to be the new column type, and then just a cancel and add variable button. Now, new call, that's going to be that well panel that consists of the user input for a new variable name, the label, the reference variable, specifying the number of conditions or groups, that else group checkbox, and last but not least, your distribution of the reference variable. So range conditions, of course, is going to include what's left. There's a well panel at the bottom that dynamically updated depending on the number of groups that are desired in the final variable. So overall, that's kind of where you can see each module in the app. Now let's talk about the different inputs and outputs and the activity that's happening inside of each module. So what do I mean by that? I'm really talking about how app.r is going to pass information down to launch modal and consecutively to new call and finally range conditions. And after that, how range conditions is going to pass information back up to new call, launch modal, and finally land at app.r. So to start us off, the code that's required for app.r is pretty minimal. So you're only going to need to call this module here called launch modal. And the first thing that you're going to need before that is to library shiny new columns and or use the typical prefix of the package name : prior to each function. So user interface just accepts the typical shiny ID tag that's needed, and then it creates a button. The server side is just going to collect the same ID, but it's also going to ask for that data set, which you can specify here. Notice that it does output an object as well, and we call that out. Okay, so now if we're to go through each of the consecutive modals, we already covered this creates a button in the modal itself on the server side. But I'm a huge fan of reactive values, especially for updating data sets between or over many different observe events or reactives and things like that. So reactive values does a good job of allowing you to play with the data outside of your typical reactive objects. Okay, so it's getting past the data set, and you can see we're putting that right into the reactive values object. And then we're simply going to call the new call module, and we're going to give it two things: the same data set, so the iris data set, and then we're going to pass along the column type. All right, so let's pass those on to new call and see what we do with them. New call, this is the user interface, basically just the well panel that we touched on before, containing all the info that the user needs to specify about the creation of a new variable. And from there, we're going to call range conditions. So range conditions is going to accept basically all those user inputs. So it's going to ask for the data, the number of groups, the reference variable, and then if you created some else groups, it wants to know about those as well. Okay, so finally, range conditions. This is the well panel at the bottom where you can see we specified our reference variable is going to be between a numeric range to create group 1 and then another numeric range to create group 2. It's finally time to create some dynamic user interface elements. And the way that we're going to do that is using reactive text strings. So here you can see we're just making a text string for these different IDs that we want to create for Shiny inputs. So here we have some low, some high, and then some then names and some group placeholders. And you'll see where those come in handy next. All right, so this is the spot where we are rendering our user interface. So we're creating those Shiny inputs. And the way that we're doing that is basically we've set up one big fluid row and we've created multiple columns within that fluid row. And inside each column, we're just simply going to use the map suite of functions from the per package. Comes in handy quite a bit here. So first and foremost, we're going to start off with a simple a string that says when the reference variable is between, and notice we've added just a little CSS class on that to add some padding. And then next we're going to map all of the Shiny input IDs for this numeric input. And so that's going to populate this .x variable that we see here. Notice that we've made the label null for all of our inputs, so that doesn't take up any space in the UI. And then we're going to set an initial value. If there was a previously entered value for this input, we're going to use that. Otherwise, we're just going to use the minimum of our reference variable. All right, then we're going to add the word and between, and then we're going to do the same thing, but for all of our high Shiny input IDs. So here we're saying let's create high number 1 and high number 2, and we'll do the same thing. So if there's a previously entered value, we'll use that. Otherwise, we'll specify the max of our reference variable. And then last but not least, we just need some placeholders for the different groups. So here we're mapping two things. So we've used the map2 function, and we're mapping the then names and the group placeholders. And the very final thing that we see here is we're just adding a text string statement that counts how many rows are falling within those numeric ranges. All right, so after we've done that, we've created our user interface. Now it's actually time to pull those values out of the Shiny inputs. So here you can see we're using the per suite of functions again. We have map double. We know that the final result is going to be a numeric value, so we'll just put double in there. So instead of returning a list, it'll return a vector of doubles. So here we're going to map, again, those Shiny inputs for low and for high. And then we're going to use this function called default val to get the value. So basically, this is just testing, like, if this value is truthy, then we will use it. Otherwise, we'll use some other value. So for example, we're saying if there is an input value, then that's what we want to extract into this vector of doubles. Otherwise, we'll just put some NAs in there. So we're doing that for all of our low values, all of our high values, and then all of our names that we gave to the groups. Okay, so now we are taking these values. You can see that we are using pmap, so another fun function from the per package. And it acts very similar to map, except for we can just give it a list of values and supply it to a function. So here you can see that we're using a function called between, and we have the reference variable, the all of our, remember this is our vector of low values, this is our vector of high values, and these are the names that we want to give them. And you can see that we're putting those into something called build case one formula. If you want to see what that is, you can see it's basically just a function that we want to apply here. And you can see it has 5 elements, just like we've made a list of 5 elements to feed it. And it's simply going to call a number of rlang functions on here. So we're going to turn this into an expression at the end of the day to make a between statement. So it's important to note that we are actually going to be returning this between expression up to the new call module later. But for now, we're actually going to start to eval this module at the range conditions level because we want to be able to count how many rows exist between each numeric range. So what we're going to do is we're going to start to leverage something called call to and quote. So call to is a handy little function which basically allows us to call a specific function. So here you can see we're calling dplyr mutate. So we can reference that within a quote function, and it won't actually call the function right away. And then the second argument is going to be the actual expression that we're interested in calling with mutate. So here you can see we've inputted our column name, and by default we just call it new col, and then later we'll substitute the actual column name in there. Then you can see we're doing the same thing down below. We're doing call to quote, and we're saying case where we want to use dplyr case one to evaluate this between expression. All right, so we're going to take that mutate expression call and we're going to insert that directly into a list called all expressions. Now, what else is included in this list? Well, first we're going to select the data, and then we're going to select the reference variable from that data, and then we're going to call the expressions on that variable. Okay, so next we're going to create a mutated data set. So what does that mean? We're actually going to evaluate some code. So here you can see we have all expressions, which as I said before is just a list of expressions. And we're going to use per reduce to actually turn those expressions into a piped formula. And then we're going to feed it right into eval, which is from base R. So now that occurs, this is going to be an actual reactive data set, and we can just use it like a normal reactive data set below to calculate our row counts. All right, so that's all we needed to do at the range condition level. So now it's actually time to pass those values and objects back up. Specifically, the between expression is what we're interested in using. So let's pass that back up to new call. You can see that the output from the range conditions module we called module expression. So now we're going to use that elsewhere. You can see here we're using module expression, and we're going to switch over to use the column name that we desired to use in the application. And then we're going to do the same thing we did at the range conditions level. We're going to convert this to a call to quote scenario where we select the dplyr mutate. We have the same expression here that we did at the range values level. So now we can actually pass that up to launch modal. Remember, we called that at the top level current mutate, and we put that into a reactive values object. And now we are going to simply use that. So basically, whenever someone clicks the add call button, it's going to combine any current mutates with any other mutates that have existed prior to running this modal. And then we're going to create a list of the data set and all the mutates. And then we're going to use rlang to flatten and reduce those statements as we did in range conditions. So basically, we're going to pipe each expression and then evaluate it. And then a simple statement to remove the modal, because guess what? It is time to return our data and our mutate expressions to app.r. And in the app, you're going to see everything updates accordingly. So congratulations, you did it. We did it together. can see here that we have the sepal length category, and we have some values there. We called those short in the demo. And then up over here, you can see we've generated some new code, the mutate statements and the between statements, all within dplyr. All right, so that basically covers all the module activity that we observed inside the app. So what have we learned? Previously, we mentioned that there were a few things that were difficult about today's topic, and those being the big three. First, generating dynamic UI. Next, bringing together user inputs in a meaningful way from those dynamic user interface elements. And then, of course, evaluating all the results into executable R code. So first, let's talk about generating UI. We were able to accomplish this rather easily just by making a reactive set of ID names based off of the total number of groups we desired in our new column. And then we used the map suite of functions extensively in order to create those input IDs one by one. After that, and probably the most daunting task, was to bring the user inputs together in a meaningful way and deliver them to parent modules. So we were able to do this pretty easily by combining sort of all the UI elements into their own expressions, and then we just simply bundled those into a list. And with those in list format, we were able to return them back to the parent module as a one solid object. Evaluation of the inputs became a slightly easier task thanks to rlang and base R. We heavily use call to, expression, sim. From base R, we use quote and good old-fashioned eval. So if you recall the steps we used the call to and quote duo on any returned expressions. We put those all into a list. And then we use per, flatten, and reduce to be able to evaluate each object using pipes. All right, if you're at all interested in this project, I highly recommend checking out the GitHub page, and we would love to hear from you and get some user feedback. This project has been a collaborative effort thus far. I did some work on it with my former colleague, Maya Gans, and we're unashamedly soliciting extra help. So if you'd like to contribute in a meaningful way, please open a PR, open an issue. Lastly, let's connect. My name is Aaron Clark. I'm Senior Data Scientist at Biogen. There's my personal email. Feel free to connect with me on LinkedIn or GitHub.
Thanks, Aaron, for this clear description of how to collect data in a more flexible way. And if I know Aaron is in the chat, so even though the talk was pre-recorded, if you have any questions, you can ask on chat or connect with Aaron using one of the methods that he described, like LinkedIn. Thanks a lot, and see you soon in the next talk.